Okay, here's a walkthrough on how to find the angles for the WingBox project that we're doing. Drawn here is one of the drawings from the packet of information he gave us. You see the front spar is drawn on top. The angles, the view shown here is looking down the end of the wingtip, like from the wingtip. So you got the front spar drawn at the top in red. It has a leg of 3 1/8 inches with 2 flanges. They're 3/4 inch each on each end. You got an 8-inch skin on the top and bottom of the wing box, which is drawn on the sides of the drawing as is depicted here. Then you've got a rear spar at the bottom of the drawing that has a leg of 1 3/4 inches with 2 3/4 inch flanges on each side. Now the angle we're trying to find, that we'll find first, is going to be the angle that the piece of metal here needs to be bent. So if the green line represents the pre-bent piece of sheet metal, the angle that we're going to bend it up is this right here. So we need to find this angle. And from geometry, if you'll recall, that angle there is going to be the same as this angle here, and we'll call that theta. Now, we can utilize a right triangle to make the math a whole lot easier by drawing a line here. So now we have a right triangle with an unknown angle. We're going to have a hypotenuse here, we'll call that H, and then a leg or a triangle up here, which we'll call A. Now recall, way back from the first week of class, the cosine of any angle we'll call theta is going to be equal to the adjacent side over the hypotenuse. Now if we know adjacent and hypotenuse side, then we can calculate theta by doing the inverse cosine. So in our calculator, we can plug in cosine inverse of A over H, and that's going to equal theta. So let's go find A and H. So here on, let's start with H. On the side of our box here, this whole skin, the whole length is 8 inches long. You can see here, the whole thing is 8 inches. So H is going to be the section of the skin subtracted from the 8, and also subtract off the 2 3/4 inch flanges. So we can calculate H by saying H is going to be the whole thing, which is 8, minus the top flange, which is 3/4, minus the bottom flange, which is also 3/4, and that comes out to 6.5. So we know the hypotenuse of a triangle we're working with is going to be 6.5 inches. Okay, now what about A? How do we find A? Well, by looking at our diagram, we know this box is symmetrical. So we can draw another line up from the bottom here, and now this subsection of the top line is going to be 1 3/4, and then it's symmetrical, so we know this side over here is also A. So once again, by doing a similar calculation, we can then say 3 1/8 minus, which is the whole front flange, minus the length of the bottom flange, which is 1 3/4, minus 2A is going to be equal to 0. Now that was kind of weird how I did that, so let me go back through it. So the whole thing is 3 1/8. That has to be equal to 1 3/4, which is this part here. 1 3/4 is that middle green triangle, and then we have 2 A's over on each side. So we can say 1 3/4 minus 2A is going to be equal to 3 1/8. So if we solve for A, then we find that A equals 11/16. So now that we know A and we know H, so now we can plug those numbers back into our inverse cosine formula. So we can say inverse cosine of 11/16 over 6.5 equals, and that comes out to 84 degrees. Okay. So we've got theta, which is 84 degrees, And because theta is also equal to this angle up here, that's also theta, so this angle is 84 degrees. So that's how far we're going to bend our metal. It's 84 degrees, and that makes sense. We know that the flange isn't going to bend 90. We know it's not going to bend over 90, so 84 degrees makes sense from a common sense check. So now then, let's find the other angle down here. I'll use blue. So we need this angle as well, because that angle is going to help us find this angle. So what I just drew was the angle that we're going to bend the sheet metal for the rear spar. Now we can observe that that's more than 90 degrees. So when we finish our calculation, we need to come back and figure out what it is. And if it's not more than 90 degrees, then we know we did something wrong. So once again, from geometry, if we know, let's figure out this angle here, which we'll call phi. All right, so remember a triangle has 180 degrees in it. So if you add up all the angles of a triangle, it's always going to be 180 degrees. So we know that theta is equal to 84 degrees, and we know that it's a right triangle, so we have right triangle, and that angle is going to be 90. So therefore we can find phi by saying 180 minus 84 degrees minus 90 degrees for the right angle, and that comes out to 6 degrees. So know that phi is equal to 6. All right, well, what does that tell us? Well, it tells us that this complementary angle to phi, this one here, is going to be 90 minus 6, which is 84. Okay? Now, what does that tell us? Well, we can look at this line here and pick a new color. Go with orange. So this angle here is just a straight line. It's 180 degrees. So that's going to tell us that the bottom angle, the angle here in green, the angle we need to know, is going to be 180 minus 84, which is 96 degrees. So the angle of our bend from here all the way around to here is going to be 96 degrees. And that makes sense. That's more than 90. We know it needs to be more than 90. So problem solved.